Welcome to our online class. Today we'll be taking homogeneous first order differential equation. You might be wondering what exactly is homogeneous. Homogeneous, when you say something is homogeneous, they have similar characteristics, Take for instance, you have a function of x, y to be equal to x squared plus 3xy plus y squared. Now, you might be wondering what is homogeneous in this. Now, what we are concerned about is the degree. When I mean the degree, the power. The power of this, you can see this is 2. And here I have the power of x here is 1. And the power of y1 is 1. So 1 plus 1 gives this a degree of 2. Likewise, y is also of a degree of 2. So what we have here is homogeneous. Likewise, everything we have here also, they are homogeneous. If you look at this, you have a power of 2, 1 here plus the 1 of y gives 2. So it means once you see this type of question, they are homogeneous. And you use homogeneous approach to make your work very easy so that you can arrive at the separable method. Now we are going to divide something here. Let's say y equals vx. This v is a function of x. Now if I differentiate y respect to x, I'm going to have the y, the x to be equal to, if I differentiate x, I'm going to have 1. So I keep v constant. I'm going to use product rule for this right hand side. Plus, now, if I keep x constant and I differentiate v, don't forget I said v is a function of x just like y. So I'm going to have dv dx. It means anywhere I found the y dx in my equation, I can replace or substitute it with v plus x dv dx. Likewise, anywhere I see y, I can easily substitute v and x. Then the equation what will be solved. So let us try the first example here. This problem number 1. So this is solution. Number 1, you have the y, the x to be equal to x squared plus y squared over xy. That's a full pass question. Now, we said the y dx will be replaced with what? V plus x dv dx, right? Now, so I'm going to have v plus x dv dx to be equal to x squared plus, now this is y squared, will be replaced with what? Vx. So that will be vx all squared, because this is y squared plus v squared x squared divided by x multiplied by y, and my y is vx multiplied by vx. Now I have v plus x dv dx to be equal to what? X squared plus v squared x squared. If x multiplied vx, I'm going to have vx squared. Now I can see that I can factorize out x squared at the numerator here. So I have v plus x dv dx to be equal to x squared into 1 plus v squared all over vx squared, right? So x squared can cancel out x squared. Now I'm going to have v plus x dv dx to be equal to what? 1 plus v squared all over v. Very good. Now I can bring this v, that is I subtract v from both sides. So I will have x dv dx, bring v to this side, 1 plus v squared all over v minus v. So I'm going to take the least common multiple, that's LCM, and that will give me x dv dx to be equal to what? 1 plus v squared. If I make v the LCM, multiply this, I'm going to have negative v squared all over v. So this can take care of this, right? Very good. So I'm going to have x dv dx to be equal to 1 over v. Observe that this has become the separable method, because if I bring the x here, I'll bring v here, and we have x underneath it. What I'm trying to say, I'm going to have v dv to be equal to the x over x. And I can integrate. If I integrate v dv, I'm going to have v squared over 2 to be equal to what? Ln of x plus c. Don't forget, this is not the final answer yet. Your v is from y equals to vx. So from here, I can say that my v is equal to y over x. I have to bring back my variables. Now, I'm going to have 1 over 2 into what? Y squared over x squared to be equal to what? Ln x plus c. And that is the answer. Very good. That is the answer. Now, let's take the second question very quickly. The second question is x squared equals to y squared yx. X squared equal to y squared dy dx. Now, all I just do, I'll divide both sides by y squared so I can have the y dx here. So I'm just going to have x squared over y squared to be equal to the y dx. And I'm going to do my substitution, right? So don't forget that this is our point where we get what we're substituting. So I'm going to have x squared over my y squared is what? V squared x squared. V squared x squared, which is equal to what? And my dy dx is what? V plus x dv dx. V plus x dv dx. X squared can take care of x squared, right? So I'm going to have 1 over v squared to be equal to v plus x dv dx. I can bring v to the side. That is, if I subtract v from both sides, I can have v 1 over v squared, right? Minus v equals x dv dx. Now, if I take the LCM, I'm going to multiply this by v squared. So it means I'm going to have 1 minus v cubed over v squared to be equal to what? X dv dx. Right? Now, again, we have arrived at something very similar to separable method. In fact, separable method, because again, I'm going to have x. If I bring the x to this side, because I cannot have x over the x, right? So I'm going to ensure that I bring the x above x. It means what we just do here, bring the x to this side and you bring x underneath. This is what I'm trying to say. You can have the x over x here. It will be equal to what? When this multiplies this side, I'm going to have v squared over 1 minus v cubed dv. And I can integrate both sides. Right? Very good. If I integrate this, I'm going to have ln x. And that will be equal to, now, remember that if I differentiate what I have here, if I say this is a, we've done this before, if I differentiate this, I'm going to be having negative 3v squared, right? Because this is 1 minus v cubed. So I'm going to be having negative 3v squared. Then v squared can cancel out v squared. So I'm going to be having negative 1 over 3 here, right? So it means from here, I'm going to have negative 1 over 3 natural. So it's going to become the natural log of 1 minus v cubed. And I can bring in my plus c. So from here, I have ln x to be equal to negative 1 over 3 ln of 1 minus, what is my v? Don't forget again, your v is y over x. Y cube over what? X cube plus c. So that is the answer. So remember, the deal is that you must be happy, I must be happy, we must be happy. So endeavor to like, comment, subscribe, and share. Thank you.